give 48 a try, and then these will be the homework problems you'll do. We're trying to take the integral of this whole thing here. You can't do like U substitution, those type of things. What we're going to do is we're going to use the stuff that we know. So if you look at that cheat sheet page, you can find what e to the x is, or you can come up with what e to the x is. So it's going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And it's good practice here for us to try to get this into this type of a form. So without cheating and looking, try to figure out what this is. So I'll give you guys a minute. Okay, so when you write this, did you guys get x to the n power on top? Shh, guys, is this what you got? X to the n over n factorial? Yeah. Okay. Now what we're going to do, take a look at this. You're going to have to do stuff like this. We're going to just go ahead and subtract 1 from what we have there. So it seems like it's going to be really difficult. It's actually very easy after you see what we're doing here. If I take what I have up here and I subtract 1, if I subtract 1 from this side, I just subtract 1 from this side. So doesn't that just get rid of this first term here? So this is going to be x plus x squared over 2 factorial plus x cubed over 3 factorial and so on, right? So if I'm writing it in this form, the easiest way to do that, instead of starting at n equals 0 to infinity, it's just like I'm starting at 1 to infinity, right? So n equals 1 to infinity, and then I can keep everything the same here. That makes sense? Okay. Now what do I still have to do with that? Divide by x. So I'm going to take what I have here and I'm going to multiply it by 1 over x. And that'll get me kind of the last step here. So if I want the e to the x minus 1 over x, I'm just going to take what I have here and multiply by 1 over x. So what's going to happen when I put that into that summation piece? So it'll be x to the n minus 1 because you subtract your exponents. So we've got this. And this turns into x to the n minus 1 over n factorial. So any questions up to that point? Okay, now what was I trying to do with this at the very beginning? Aren't I trying to do the integral of it? So I'm trying to really do like the integral of this. To do the integral, what do? Take the antiderivative. So that's what we're going to do here. So I'm going to go ahead and I'm going to say we're doing the integral of e to the x minus 1 over x dx. Okay, when I do antiderivative, what do I always have to remember in the back of it? Plus c. So I'm just going to go c plus, okay, some constant plus this. And then all I do to find what this is do the antiderivative, which again seems awful, but it's not as bad as it seems. So I'm just going to go ahead and say here antiderivative, just so you're not confused as to what we did in this step. Okay, when I take the antiderivative of x to a power, what do I do with that power? Add 1. If I add 1 to this, what do I get? Just x to the n. And then you divide by your new exponent, don't you? So I'm going to divide by n, and then I've got this n factorial. I'm going to give you a second just to make sure you understand all that. So then if we get that, we just go ahead and circle this. Now the other thing they might ask you to do is to find the radius of convergence. So if I want to find the radius of convergence, you don't have to worry about the c plus part, but then we do what? The ratio test. So let's go ahead and do radius of convergence. And this should be pretty quick. We just do the limit as we go to infinity, absolute value, and then I'm just taking what's in here And we do n plus 1 first, so it's x to the n times x to the 1. And this would just turn into an n plus 1. And this turns into n plus 1 factorial, which is what? N plus 1 factorial turns into what? N plus 1 times n factorial. So I'm kind of skipping some steps because I should be getting good at that. And then multiply by the reciprocal of base of n. And try to clean it up, see if you can get it here. So again, I'll give you a minute to catch up or get ahead there. Okay, so then here we can cancel out the n factorials, the x to the n's. So really here I just have the limit as we're going to infinity of n over n plus 1 squared. And I'll just leave it like that. And then still have the absolute value of x. And if I am taking this piece of it here, remember this is an n squared if you multiplied it out. So you divide everything by n squared. What are you going to end up with then? 0. So we should get 0 times absolute value of x has to be less than 1, right? And so what's my x going to be? Oh, reals, anything would work here, right? So our radius would be what? Infinity. X could be all reals, but then your radius would be infinite, okay? Questions on that? So this stuff down here isn't anything new. You guys catch all this stuff up here? Okay, so I'm going to give you a minute to work on these. I'll take a look at 1 and 3 to see if we need some lesson stuff on that or if you can try those. So, okay, when you're doing number 1, I was able to get the answer because I've probably done it before is why. It's going to be similar to what we did down here, okay? So you might have to reference that part of your notes where, remember we were trying to find like what the fifth derivative at 0 was using what we had up here. You might have to reference that, but I can definitely help you with it, but I want you guys to try it. If you need help with it, I can help you with it tomorrow. Okay, so doing 31, e to the x, you should get this part here. And then e to the 2x, you're just replacing the x's with 2x's, so this will be 2x to the n over n factorial. And then the whole goal of this problem was to add those two together. So if you're adding these two together, you're just taking what's inside here and adding it together. So I've got x to the n over n factorial plus the 2x to the n over n factorial. And in order to add fractions, you have to have a common denominator, and they have to be like terms. Do you see how they're both x to the n's? Okay, so this here, you'll have to split up that numerator. Okay, so you're going to split this up. So this will be like 2 to the n times x to the n over n factorial. Does that make sense to you guys? So you have the like terms in the back, and then you just add these two pieces together, which already have a common denominator. So when you add them, you leave the denominator the same, and the numerator, you just add those, and then you just have the x to the n in the back. So when you add these together, that's going to throw this out front. And I think that's the answer. Let me just double check it here quick. So that's 31, and then you have to find the radius of convergence off of that, which you guys are pretty good at.